Hello everyone, welcome to Zeref Game Dev. In this video, I am going to create the Tetris game in Unity. So let's start by creating the game. So I opened up the Unity editor. It's an empty scene, so let's delete this scene and let's create a new scene first and we'll call it gameplay. Let's save the scene as a gameplay. And let's delete the sample scene. So after deleting that scene, let's create the prefabs folder and the scripts folder. So there is only going to be one prefab and I won't be using any fancy sprites. You can use your own. And the script is just going to be the game manager script. It will control the whole game. So if you want, you can save everything in the base folder or whatever is at the beginning. But I always create the folders for that. So depending on your preference, you do it yourself. So let's set up the screen first. So it's going to be a portrait high, and let's add the title text, and let's call it title, and the title is going to be Tetris, and you can have anything like a logo, not logo, whatever the game name it is or whatever you like, and let's set the main camera to white. And after doing that, let's set its width to 1000 by 150 and let's set up the canvas. So inside the canvas, instead of screen space overlay, let's set it to screen space camera, and for the render camera we'll pass the main camera and we'll set it to scale with screen size, and the reference resolution will get at the 1080p and will match width and height equally. So this will be the camera sets, and inside the title text let's increase the size and let's align it to the center and position towards the top, and x is going to be 0 and y, let's just position it at -75, and if we increase the size to like 96, we should be able to see the title. Now similarly, let's create the two buttons which are the start and the quit buttons. So let's create a button and let's call it start, and it will just restart the game. So let's position it towards the top, and from the y it will be -75, and let's position x at 0 and let's set its color to transparent. It will just show the text, and we don't want any transitions for the button. Now inside, and let's change its size, so 500 by 150, and inside the text we'll set a text to start, and let's make the size 96 so it matches the size, and let's position the button at -350. So this one's for the start. We'll duplicate it again and I'll call it quit the game, and inside the text it will just be the quit, and it will be positioned at the +3. And let's create the game manager. So we'll create an empty and let's call it game manager, and let's reset its transform and add the game manager script. And inside the game manager script, we'll need to create the game start and the game quit function. And before that, let's create the prefab. So the prefab's going to be a square, and I'll call it piece. It won't have anything, but we'll set its color to black and let's reset its trans. So for now, the scene is pretty big, and let's it's positioned at 0, 0, and we need to span across the x-axis to be 16 times because it will be the width of the grid, and along the y it needs to be 21. So let's set the camera size to 15, and let's position the main camera at 7.5 and -7.5. So it will be positioned at the start. Now if you change the piece position for the x to 15, it will be towards the end. So it starts from 0 and then it goes till 15. So there are it should fit 16 cells in the x-axis, and similarly for the y, it should go till -21. So that's for the piece. Now let's save the piece as a prefab. We'll instantiate it in the game manager whenever we want to create a new, and depending on the piece, we'll create it. So that's it for the scene. Now everything we'll do, we'll script it in the game manager, and then we'll check for uh, any code we are adding if it is working. So let me open the game manager. So I'll open the game manager, and I need stream tabs. It's opening. So let's go into Visual Studio and little bit of racks, raw diode, dev environment. Okay, so here's the Tetris. So I opened the Visual Studio code and Visual Studio editor, and here we have the game manager class. So inside the game manager class, first we need is to instantiate the objects. So to instantiate the objects, let's first create the struct first where we are going to store its position. So let's set it to be public and it's going to be struct. And let's just call it grid, and in it will have the integers, so public int x and y. It's set it to public because you need to edit it. If we don't set the public, we will only be able to initialize when we create a new grid. So after doing that, what we'll do is let's create get the game piece. So it's going to be serialized field and game object, and what we are going to get is the game piece. And after getting the game piece, let's add the awake function. So after the start, we should be able to get the awake function. So inside the awake function, first what we need is getting the positions or the start positions. So to store the start position, we'll create a list of grid. So we'll convert that position from grid to the transform, and it's going to be current indexes, and I'll create one more. It will temporarily store a grid, and it's let's call it temporary indexes. And after that, we need to store the game objects. So let's create a list of game objects too, because for each piece we need to update its positions, and we'll call it the current piece. So for the current piece, each piece will be a piece, and after that, after getting the index, we will need all the pieces position. So it will be a list. Each piece position will be a list of grid, and for all the pieces, it will have a multiple list. So I'll just copy paste it because it's a pretty long list and not much long, but I'll just copy paste so you can see how that list is created. So the first thing it has is it will initialize this variable, the pieces, and after that, inside the pieces, each member is a new list of grids. So uh, inside each pieces, we have multiple pieces, and each piece will have that four squares, and it has all the positions, how it will look. So depending on the pieces, we'll instantiate the game object at the start location. So let's go inside the awake, and inside the awake, let's just set current indexes equals to list of grid, and the temporary indexes to the new list of grid. and the current pieces to be a new list of game objects. And after getting the game objects, we need to set first so we have got the game objects, and what we'll do is for int I is equals to 0, I less than dot count pieces of n. Now, which game object will need to spawn is let's get a random from the list. So it will be n is equals to random dot range from 0 till the this dot count. So it will get a random piece from that list, and after that what we'll do is for that pieces of n, whatever that n, and for each index we'll create a new game object. So uh, let's create uh, let's first create a grid, temporary grid, and it will be a new grid, and here will not a new grid, we'll get it from the pieces. So for the pieces at nth piece, and we'll get the ith position, and it will be stored inside the temporary grid n comma I. And after that what we'll do is we'll increase its count. So we need to position at the center. So we'll set the start position, we'll add 7 to the start position, and after adding the 7 we'll add this temp grid to the current index. So current index dot add the temp grid, and inside also the temp indexes add the temp. So the temporary grid and the current indexes grid stores this position, and depending on this position will instantiate the game object. So again, let's do a for loop, and inside we'll pass the current indexes dot count, because now we don't need to get the reference from the piece. We have stored its position in a current in list of grid, which is current index. And let's create a temporary object, and we'll initiate a game piece, and after instantiating it we'll set its transform dot position. M dot transform dot position is equal to vector 3. We pass the current indexes at I dot x and the current indexes at I dot y. And for the y we need to add the negative sign, because we are counting it positive, but inside the game it's setting up negative. And after that let's add it to the current piece. So inside the current piece dot add, we'll get a reference for the temp, and after doing that it should be fine. Now let's create a 2D array to check to store the positions of whatever the pieces are already placed. So I'll create all the variables now. We have the variables for the game piece, then we have the variables for the current piece, and then we'll need a dictionary which goes from grid. So it will store the game objects for each grid. So if the grid is empty, it won't store anything, and let's just call it grid objects. And we'll need it when we need to delete the objects and can't get text, because text just stores objects. And we'll need a float of wait time. So depending on the wait time, we'll set up the how count or how fast the game is to go. And next up will be a boolean, and it's going to be a 2D array, and let's set it to be bool. And inside the boolean let's pass x indexes and the y indexes. So after doing call it just uh, so after doing that The fill should be, and we need to set the fill to false at the start, and we need to have uh, some more variables. So the first one is going to be the direction when we move left or right, and two booleans, which are the can rotate and the has game. And in the awake function, let's set up everything. So inside the awake, after the current pieces, let's set the direction to 0, and the grid objects can rotate to false and has game finished to false. And then we'll have the default wait time will be 0.3 seconds, 0.3 f, and after that we'll have the dictionary for the grid objects. So the grid objects going to be a new dictionary, and after doing that, what we need to do is we have added the position. Now let's set up the dictionary first. So for int I is equals to 0, I less than 16. So for the x, let's add one more. For int j is equals to 0 and j less than 22. So it goes till, and what we'll do is we'll set the fill at the x, the jth index before. So this is just going to be the awake function, and let's see if it is. Sure, yeah, I did change. Sometimes I forget to change it to it. So let's go inside Unity, and we should have a P. The field game manager assigned but is never used. Okay, we don't need anything. Now let's hit play. So it should spawn. Okay, we need to assign the game piece. So inside the game manager, we have not added the tab. So I'll add the piece. Let's just delete it. Let's hit play. And when the game starts, it will spawn an object. Now I have not created the game restart and the game code function, so I've created it now. So it's going to be public void game restart, and I already done that in multiple videos, so you know how to do. So we'll just go from unity engine dot scene management dot scene manager dot load scene 0, and I'm not showing it in Unity. I'll just share it. So this one's going to be the game restart, and next we'll have for the game quit, and here we'll just set application dot quit, and is inside the Unity editor. So hashtag hash Unity editor will go inside the Unity editor dot editor application, and we'll set the playing to false and end the end if. And now let's go inside Unity, and we should be spawning random pieces at the start position. Now when we go inside Unity, let's add the start and the quit button functionality. Add the list, add the game manager, and this for the start, so we'll call it game restart, and similarly for the quit, we'll have the game manager, and let's call it game quit. Now let's hit play and let's check for the quit, and similarly let's check for the start. So a random piece is always spawned at the start position, and set the start position to be a little bit higher, but I'm just setting it here for now. And after doing that, we should be, where's the piece? Let's add a random piece and see if everything working inside correctly. So the scale is a little bit larger, and let's hit play. Let me check scale. Oh, okay, the scale is all right, but I'll see if it goes to -21. Okay, it goes till -21. I'm just larger. So now we have instantiated all, we can instantiate all the game objects. So after doing this, what we need to do is move the player down. So we'll create an enumerator, and inside the update, we'll get the input. So inside the update, let's add Visual Studio, and inside the update, first we'll check if the game has finished, then we'll just return. And if the game has not finished, then what we'll do, if put.get key down, and the key we need to get, key code dot, let's do for the left. So dot a, then we'll set the direction to be the -1 because we need to do the negative. We need to move to the next left direction, and similarly inside D will set the direction to be positive. And after that, if we press W, let's just copy. If we press W, then we'll set the rotate to can rotate will be set to, and the last one's going to be for the S. So S downward, it will increase the speed, so will decrease the time. So it will set the wait time to 0.1 f. Now so uh, let's create the enumerator, and let's start the. So after we add the update, so we have added the update. So after the update, let's add the enumerator, and we'll call it return. So because update, and the first thing we'll do is we'll return. Wait, we'll update the times. We'll return. Wait for seconds. And the seconds we are going to wait is the wait time. So depending on the wait time, and inside the start, call start coroutine, and the coroutine we are going to call update. So the first thing we need to check is the direction. So let's update the direction, and then we'll update the position of the game objects. So if the direction is 0, then it will update. So we'll just slide by direction and update its position. So after doing the update turn, what we'll do is for int I is equals to 0, I less than current indexes dot count. Let's get the grid at that location. So int indexes dot I, and we'll store change the temporary indexes because we need to get the current index. If it is not valid, then we Right. Inside the temp grid, add the direction. We are moving in the positive direction. Add 0, add 1. And we'll set the current indexes to be the temp grid. We move left or right, change its transform. And after that, what we need to, let's just do it like this and then update the position. Let's do for int I is equals to I less indexes for count. We need to update the position for count, and what we'll do is, let's first get the game object. uh, so game object, and let's call it just, we'll just set the position. Current pieces of I or transfer is going to be new vector 3, and what we are going to pass is current indexes I dot x, current indexes at I dot y, but it's the direction will add. It should update the current index, and then we'll call the start coroutine. So we'll set the direction to 0, so it will, if we press it again, and then we'll call the coroutine again. Coroutine we want to start as update. So let's see, we should be able to move the game piece left and right, and okay, and left we should be able to move left, and right we should be able to. So as you can see, I'm over the left, over the left, over the left, and for each of the pieces we should be able to move. Now it goes beyond the index when you take a condition for that, and not move, so we need to add that too. So before moving downwards, let's add for the rotation. So here we need to check, and what we are going to check, the check return a boolean. Inside the check, let's just return false. That will just, let's return false for now. And what we need to check, if for each of the indexes, if that index position is valid and that index position is empty. So if everything passes, then it will return true. So we'll check for I is equals to 0, I less than current indexes dot count, because we are changing current index, and if the current index is at I dot x, x should not be less than 0. So if it is less than 0, or it should not be greater than or equal to 16. So if it is 16, an error. Similarly, y position should not be greater than or equal to 22. Current index is dot y, because it goes to, then what we'll do is return false, because the check is, and the position, else if we have something at the current location. So for the fill, what we need to pass is current indexes of I dot x, current index at I. If it is true, then means if it is already filled. Then also, so this will return false if it is out of index of if it is already filled. So it is set to true already at the beginning. And now we need to check when we move towards the left or the right. What we'll do is we'll do a check and we'll update it accordingly. Let's do the check here. Check. Check is going to on the current grid, and what we'll do is update the current indexes dot count. We'll update the current indexes of I to be the temporary indexes of, because we have stored the previous current index before changing it. We have stored it in the temporary indexes, and if the check is not correct, then what we will need to do is we'll update the position. So I'll just copy it because we'll update it at the end. And after doing that, we should be able to move only from the negative 0 till the 6x. Let's go inside Unity and let's check. So let's set these two and let's see if we can only move towards the left. So if we are going towards the end, we'll not move and the position not shift. Only towards the right. So when we did this, we should have changed the current index. Okay, so current that's for the left and the right. Now we need to check for the rotation. So the rotation, just the calculation is going to be different. Everything else going to be same. What we need to check is if we can rotate. So if we can rotate, uh, I'll go inside. So first we'll check is if we can rotate. And if we can rotate, let's get the midpoint. So the midpoint is the first square. And for the midpoint, what we'll do is for each object in the current indexes dot count, we'll update its position. So its position will be updated. Let's get the current index. So we'll call it current indexes at I. So this one's going to be the temporary grid. And before doing that, we'll store it inside the temporary indexes. So if the position is invalid, so we can get it. And for it, X position is to be, I don't know how it works. I think it's using the 2D vector. Vector we are using minus, and then we'll get the point depending on the length and already know 2 points and the angle, so we can already get. So so after setting the current indexes, the first thing we are going to do. So if pass the check, and if it is true, then update the player's position. And if it is not true, then what we'll do is we'll update the temporary index. So it's just going to be simple. There is nothing different. Temporary index. And after doing this, we'll be able to move the piece. And let's just add the into direct downward, but we'll just add it direction. So we'll do indexes count, and it will happen at every tick or turn position, and mgrid.y plus equals to 1, add 1 to the grid, and let's first set the range. So it stores the last necessary. Is messed up, able to get the working current index already goes beyond it, and we need to get the temporary index, but with current index here we'll get it from the temporary. Set the current index at I, the and this this one. If this is false, then we'll instantiate a new. After that, oh, wait. Ah, yep. Let's just see if it is already moved. Check current piece. Unit A. Eight we need turn if direction. We need to change the update wait time. The check. It's going to check can't move downwards. When we can't move downwards, we'll instate a new. So let's check again. Uh, Unity, then we W, be able to go to the left and beyond cannot any condition for the check. So let's add inside the check. First thing we need is don't be check. Maybe the position is correct, then and if the position, then what do we need? So the position is incorrect. We need to do is update the fill for the because we need to tell to the grid that this already. Then to pass the current objects grid objects because we'll after doing that we'll instantiate a new piece and set up the current objects and the current piece. Let's do first thing do is set up the fill for entire is equal to 0 I less temporary dot count, and temporary indexes store the correct position because check the current index is valid. Here, pass the fill index I dot x, temporary at I dot. So stores the function for the grid objects at the temporary indexes of this one will be set to current piece at the so we can get. After that, we need to do is object we are going to instance it is going random of this object. I I told you what I did was if it is invalid and we set the x the y position to true, so it is already. Then we'll get a reference. Right? We'll instantiate a new piece. We have already done this grid temporary axis, current pieces, and the temporary current piece, current in, and instead of add, what we need to do, we'll set up I suppose already added it to add or not sure. Equal to similarly for current piece not add current piece of I. After doing that, we should have instantiated and the position is already set. So I have already said if again when we instant again we'll do a check. If it's not passed, then game because when we created the new object position empty and after doing that and if we have spawned a new object if we press W the wait time was set to 0.1 f. We need to set the wait time to the 0. Have spawned a new object and the technique. So let's hit play. It should work. If you don't get errors, you good. We are object because maybe yeah. Okay, okay. Why we are not spawning? Can't control that new. Did we set the ref correctly? Are fine. For the start routine, check not. So if it is invalid, problem with the not scared. Told you no, you need to get errors. Then only you will run to debug because this will be just smaller errors, and you need to catch the errors fast. Don't catch the errors fast, the game won't. And you finding errors days and hours, and then what you need to do, grab the is it or create the game patch. It's just too much time consuming. So we can already see that almost and add this every piece on the board. If you want, you can add color to it, but I am just as it. Now, what we need to the only remaining condition whenever we move that line and update the line, oh, it's going to be difficult. Won't have any errors here. So let's go inside later. This one is going to check after we have finished everything. Have moved, checked, and we have done everything else. Check for each row. Goes towards the bottom. So it will start from A1 and it will check that row is 10. So the filling is done correctly because we are able to patients problem with it. Do whatever we now it's just going to be the check for each. So let's add a for loop. For int I is equals to 0, I less than not I is equal. I start the first x to be greater than 0 get the mark and mm, maybe zeroth index. I don't think zeroth index will need working because if we are only decreasing the zeroth index, because maybe you can do it, but so let's first do is the that we'll need to pass a parameter. Just let k less than. So the y position goes from 0 till 16, and what we'll check is if it has filled. Then the first thing we'll do is we'll return if any of the position is not filled. So if not fill at k, and then return false. So the check row should work. So if check that row, so if check row pass row, what we'll do is void row. And row is and we have already checked, then it will decrease by 1. Or we need to be able to check that index again. We'll just increase the I. Yeah. When we increase it, we'll decrease because that index is already deleted to go towards the new index is already moved towards the. So inside the update row, let's just first delete. Yep, let's just first all the for int j. So whenever it is filled and it starts from and goes till, let's get the game object and we'll get that game object from a grid object. So if grid objects dot get value, and what pass grid, inside that grid position will be j, and y position is going to be the row. If we get that, try get value, comma, it inside the temporary object, get that, if it false, and we'll remove it from the grid objects. Whatever is set key or value, and after removing that, we'll update. What will update? We'll update each row's position, starting from that row to be the upper row. So let's do a for loop again, and inside the for loop, let's just call it j. We need j to be equal to I. We need j to be greater than always versus k is equals to I, j greater than 0, j minus, but we'll start from j, go till the 16th, and what we'll do is the fill for the k, which is x position, and j, the row. At that position, we'll set it to be the previous row, j1, the j minus. Did we pass it as k? Passed it. So it starts from I and sets each row's position to be whatever is at the row above. And similarly, let's add one more row, and we need to set it for 16, k is equals to 0, k less than 16, and we need to set the start to be false. So it updates the position. Now we need to change the references in the dictionary. So let's first create a new dictionary. So inside dictionary, which goes from grid, and it goes to the game, and I'll just create temp dictionary, and it will new dictionary or type. And what we need to check is in the key value pairs. So let's do for each, and let's get the key value pair goes from grid to game object, and I'll just call it pair, and we need to get inside the grid objects. And what we need to do is let's just get the key grid first, and we'll set the key grid to be the pair.key, and let's get the game object, and let's call it the current object, and we'll call it pair.value. And after doing that, we first need to check if the key grid dot y, which is the y because it is the rows index, if that rows index is less than I, because we have deleted and moved that row, and if it is less than I, inside the dictionary we have not changed anything, now we are changing it. So we'll increase the key grid dot y by 1. So before that, if it is not, and what we'll do is we'll just set the temp dictionary for the key grid to be the current object. But if it is less, then we'll update its position and set up the transform. The current object dot transform dot position to be a new vector 3, and here we'll pass the key grid dot x, negative key grid dot y, and the -1. So the dictionary is updated, and we set the grid objects to be the temporary dictionary. So after doing that, I think everything's working correctly. There should not be any errors. So let's just go inside Unity and let's now hit play. The first thing, we should not get our errors, because creating an error-free game is the final. And let's now try to fill a row. And I'll try to fill multiple rows because the code is completed as I intended to, and it should work as I want. And let's start playing. So there are no errors till now. And if we fill this one, we should be able to remove that grid from. Should remove. Okay, so it decreased. Code is working fine. Now let's remove a couple of more. So it decreased again. And now let's remove two. Yep, two twice. That fits. And I'll try to remove the at the end. There should not be any errors. Everything is fine. Get this. Now, multiple conditions should also work fine. Now we next. So, okay. So now it should move by 1, 2, 3, 4. Okay, it moved, and now we can play it again, and the game is working perfectly fine. And did I? Yep, I am inside Unity. So that was it for this video, and the game is working perfectly fine. You can add a beautiful UI or this or speed, good sounds, and it will look like a game. I'm just doing the coding part, so you can create it yourselves. So that was it for this video. If you did like the video, do like and subscribe the channel. And if you want to support it, I'm going to create a Patreon or buy me a coffee, because we all need to earn something. So see you guys in the next video. I'll update it when I create a